This is our beginning. This is our first chapter. One thing I want you to be very aware of is that these presentations are going to assume that you have already read the chapter and that you have probably practiced in Alex already. So you should have a small background about what we're going to be discussing. The way I set up my presentations are going to be based on problems. So I'm going to present a problem, we're going to discuss some of the topics, and then you're going to do problems as we go. These problems are what we call the daily work, which is 5% of your grade. So as I do the presentation, as soon as I show a daily work, pull out a piece of paper, write down daily work 1.1 or whatever number is on the screen, answer the question, continue doing that through the whole presentation. When you are done, upload it into Canvas using the proper link provided. That said, let's go ahead and begin. So this is chapter one. Chapter one is the shortest one we're gonna have. So every other chapter, expect to have several videos breaking it down into a small portion. This one we can do in only one portion. So chapter one's theme is the chemical world. So basically the world is made out of chemicals. So the way I do it is by showing you the objectives that we're gonna meet at the beginning, and then at the end, as we do each one of them, we're gonna reflect to see if we actually got it or not. So what are the objectives for chapter one? Number one, recognize that chemicals make up virtually everything we come into contact with within our world. Number two, identify and understand the key characteristics of the scientific method, observation, the formulation of hypotheses, the testing of hypotheses by experiment, and the formulation of laws and theories. And number three, identify patterns in data and interpret graph. I know you know how to read. The reason I'm reading this for you is because I want some of these concepts to start to get incepted into your brain. Hopefully, since you read the book already, this is already taking place. This is part of the learning process that we need to accomplish. So what we're gonna do now, and this is the only time I'm gonna explain all this. Chapter two, obviously, you will know that what we're doing. What we're gonna do now, we're gonna break it into the each objective, and we're gonna do one at a time. So let's begin with the first one. So the first one is recognize that chemicals make up virtually everything we come into contact within our world. And I want to bring the attention to the periodic table. So as you can see, the periodic table in here, the periodic table is what we gonna consider the building blocks of our reality. Everything we can see, virtually everything we can see, is made out of these elements. It's like having a big bag full of Legos, and everything you can build with it can only be built with those Lego pieces. So that's what the elements are. So anything that is made out of those elements is what we consider a chemical. So if you look around you, let's look at the pictures now. If you go to the grocery store and you see apples and onions and all that kind of stuff, most of them are made out of carbohydrate, which contain carbon, and carbon is one of the elements on the periodic table. They also contain hydrogen, oxygen, and other stuff. So obviously all that is made out of elements, therefore chemicals. If you go to a construction site, you're gonna see the machine made out of metal, probably iron and nickel and stuff like that. You're gonna see dirt, you're gonna see concrete, all of them made out of chemicals. You go with your family to the park. You're sitting on the grass, once more made out of carbohydrates. You breathe in the oxygen. So everything around you is chemicals. You fill up your car with gasoline, made out of chemicals. You get contaminated because somebody's polluting the air. Pollution is made out of chemicals also. So we tend to, people that don't know much, not you because you're here, people that don't know much tend to say, I don't want any chemicals on my life. Well, good luck with that, because the first thing that is going to go is your body. So usually what they're trying to say is, I don't want anything that can harm me, like for example, poison or something like that. So that's when they say chemicals, they're talking on a negative way, but they do not realize that everything around you is chemicals. Notice that the learning objective says virtually. So there are some exceptions. For example, light. Light is around you, and light doesn't contain elements. If we can go deeper, if we go into physics and all that, and you're gonna see a relationship between light and chemicals. But at this point, light doesn't contain chemicals, so we're gonna consider that light doesn't contain elements. Sorry, so we're gonna consider that light doesn't contain chemicals. So that's one of the few things where we're gonna say, yeah, that's not a chemical. So this is what I call a daily work. So we discussed that. You watch the tutorial videos on Canvas, you read the book already, so you have a lot of information you can use now. So at this point, you should be pulling out a piece of paper. You should be writing DW 1.1 or daily work 1.1. I'm gonna be looking for those labels. By the way, this work, I am not actually gonna grade it. I'm just gonna be checking for completion. However, since I have a scientific mind, there's a pattern that I'm always looking for. So if I see that something is breaking the pattern, that's gonna grab my attention, and I'm gonna bring it up to you. So if I see that the answer is very wrong, I'm gonna see it and I'm gonna say, hey, we have to review this better. So your main focus is on completing this, and I'm not gonna grade it for content, but if I see something wrong, I will let you know so you can work on it. So this is your first daily work. Basically, all I want you to do is stretch out your hand. Anything you can touch, tell me 3 things that contain chemicals. And then look as far as you can look and see if you can find something that is not a chemical. Not light. We already talked about lights, so you have to find something else. So that's your daily work 1.1. So this is a recording, so you can pause it if you want, or you can do it at the end, whatever you want to do. So let's continue. So at this point, I'm gonna say we have talked as much as we can talk about this learning objective. So the learning objective was recognize that chemicals make up virtually everything we come into contact with in our world. If you feel that we have met this learning objective, you can continue. If not, go to the book, read a little bit more, send me an email so I can expand more for you. So next, learning objective. Identify and understand the key characteristic of the scientific method, which is divided into observation, the formulation of a hypothesis, the testing of a hypothesis, and the formulation of laws and theories. So that's what we are going to cover here. What is the scientific method? I can tell you right now, before I even begin, that since you were a toddler, you have been using the scientific method. And you have come up with conclusions and your own laws. For example, once you turn like 2 or 3 years old, if I throw something at you, you're not going to try to catch it going higher. You know that it's going to come down eventually, and you're going to try to go lower or something like that. So human beings use the scientific method instinctively. We just have to formulate it so we can understand it from a scientific point of view. So this is a good diagram. This is the diagram on your book. You're going to see a lot of different diagrams, but basically all of them tell you the same, showing you how the scientific methods can be developed. So the first thing you do is an observation. So something catches your attention, you observe something, and you say, wow, I wonder if this is happening because of this, and this, and this. So from an observation, you just made a hypothesis. You're doing a educated guess based on your observation. You're saying, I wonder if this is happening because of this, and this, and this. So, so you cannot stop there because you can be wrong. So what you're gonna do? You're gonna say, well, I'm gonna have to check this. And what you do, you decide to do a lot of things, which we call experiments. So you're gonna try to test what you think it is. Or it could be something that you're trying to revise. For example, the law of gravity tells us in a very popular way that everything that goes up has to come down. So every so often, I'm gonna throw an apple on the air, and I'm gonna say, "Yep, it came down. The law is still firm." So you're always trying to revise or confirm different hypotheses. If I throw something on the air, and it just starts floating, that will really grab my attention, and it will be a strange phenomenon because it's violating the law that I know is supposed to happen. So once more, you do your observations, you do an educated guess, and you come up with a hypothesis. Then you do testing via experiments to try to confirm your hypothesis or not. If you confirm your hypothesis, then you can probably tell a lot of friends, hey, can you do your own experiments and see if you get the same results? And as people do it more and more, if everything holds and nothing changes, then you can come up with that theory. And then every so often, you're gonna test it again with experiments to confirm that it's still holding. So that's what the scientific method is. Observations, you make an educated guess, you test it, and if it holds, it becomes a theory. If it holds and holds and holds through centuries, then it becomes a law. For example, the law of gravity. So let me give you an example. So let me apply the scientific method to an experience I have as a human being. Imagine I just realized that the sun comes up every morning. And I noticed that the sun comes up every morning on the east. And I say, wow, the sun comes up on the east. And then I noticed later during the day that the sun comes down on the west. And I say, wow, the sun comes up on the east and it goes down on the west. And then I said, and then I pay no attention to it. And then the next day I observe the same thing, and the following day I observe the same thing, and I come up with a hypothesis. So my observation was the sun comes up on the east and it goes down on the west. And I see it going through the day, I see it going around the planet, the planet on the sky. So my hypothesis is here is planet Earth, and the sun goes around, and it goes around from the east to the west. So my hypothesis is, based on my observations, the sun rotates around planet Earth. So that was my hypothesis. Based on my observations, the sun turns from east to west around planet Earth. And how am I going to confirm that? Well, I'm going to wake up every day and check it. And I'm going to say, well, this is probably something that happened here on forward. So when I go to a Mexican vacation, or to India, or to Russia, or to Canada, every time I go anywhere, I wake up early in the morning, I get my compass out, and I see that the sun is coming out on the east, and it's going down on the west. So my hypothesis is holding. So I did my experiments, and my hypothesis confirmed, my experiments confirm my hypothesis. So now I'm gonna call 1,000 friends and I'm gonna tell them, wherever you are, I want you to do an experiment. Go out every morning and see if the sun comes out on the east and goes down on the west. And they do that. And I continue doing this through my whole life, and it never changed. So my theory just became the sun rotates around planet Earth. And I die. And my son believes the same thing, and he dies. And it goes hundreds of years, people believing that the sun goes around planet Earth. And then new technology is developed. People begin using math more intelligently, and they can do better measurements, and they decide one day, let's test that theory again. And they start noticing that the stars are changing positions. They start noticing that the sun doesn't come out. It comes out on the east, but it starts changing positions where it comes from. And somebody says, you know what? I think this theory is wrong. I think the Earth is the one rotating around the sun, but we get the impression that it's the other way. But based on the math and all the new instruments that I have, this theory is wrong. So we're gonna have to go back and create another hypothesis, and my hypothesis is now Earth rotates around the sun. And that's gonna be our belief until somebody else proves it any different. So that's a classic case where the observation led to the wrong, to a hypothesis that led to the wrong theory, and it held for hundreds of years. So who knows, everything we believe today, imagine what's going to happen hundreds of years from now. So hopefully you understood that. If you have any question, make sure you send me an email or put it on Canvas on the question and answer discussion. So I'm going to be checking that every day. That way everybody can benefit from your questions. So daily work 1.2. So on the same paper that you were using, continue doing the daily work DW 1.2 or daily work 1.2. And in this case, describe a situation in which you may have used the scientific method. Remember, I told you, you have been using this since you were a toddler. So think about it. You did something, was I using the scientific method? Just write it down. And then break it down into steps and tell me, this was my observation, this was the experiment I did, this was my theory. And once more, let me re-emphasize something here. The difference between a theory and a law is that the law has been holding for a long, long time, and nobody has been able to prove it wrong. So that's your daily work 1.2. So this was the objective we were trying to understand. Identify and understand the key characteristics of the scientific method. So if you understand the diagram, you have a pretty good idea. Know what observations are, know what the hypothesis is, the experiments, and what makes a law or a theory. Our last objective for this chapter is identify patterns in data and interpret graph. So if we are going to use the scientific method, we gotta be able to do observations, which is the first step, right? And sometimes this is gonna require that we collect data, and once we collect the data, like for example, the sun comes out on the east and it goes down on the west. Once we collect data, we should be able to interpret any pattern that we see develop. And then we take all the data and put it into graphs so we can communicate it better. So let's do a practice with this data that I have in here. Identify as many patterns as possible in this tabulated data. So what do I have? I have 3 samples, and they are increasing in mass. So the mass is increasing. For the carbon, I have 3 samples, and it contains carbon and it contains oxygen, so it's a chemical. And as the carbon increases, the oxygen also increases. So what pattern number 1? As carbon increases, oxygen also increases. Can I find any other pattern? I can look at the numbers to see if there any relationship. 0.5 gives me 1.3. 0.5 grams of carbon correlates to 1.3 grams of oxygen. So that's more than twice. 1 grams of carbon give me 2.7. That's more than twice also. 1.5 give me 4. That's more than twice also. So one pattern I can say is, as carbon increases, the oxygen increases for more than 2. Or I can do it better. I can see the ratio. Like, for example, the bigger number, 1.3 grams of oxygen. What is the ratio to the carbon? That's going to be around 2.7. What about when I do the next one, sample number 2? 2.7, obviously. And what about when I do 4 to 1.5? Let me check my calculator real quick for this one. So 4 divided by 1.5, that's going to be 2.666. So I'm going to call that 2.7. So you can say that another pattern that you observe is that the ratio between oxygen and carbon is 2.7. So that's what we do with data. We collect data and we can start seeing those patterns in there. What about graph? So graph is nothing more than a collection of data neatly organized. You have 2 axes, the y-axis and the x-axis, and we can see how these numbers relate. So this line here is nothing more than a collection of points that is coming from relating this data with this data here. For example, when it's 1, it's going to be about 1,810. If I had a table, I would probably have population and year. And I can say that 1 billion people happen around 1810. I can say that we reach 6 billion people I would say about 1990. So something like that there. So that's basically a collection of data. And like we did before, we can say that as the years went by, the population grew. So that's what we did first. Now we just put it on a graph, and you can see how we get a visual representation of the trend that we are observing. So let's answer these questions. What was the world population in 1950? So what we're going to do, we're going to go from 1950 to the line, and we're going to see how that crosses across. Let me try that again. And we can say that in 1950, the population was around 2.1 billion people, because that's what's telling me is in billions. What was the world population in 2010? 2010 is going to be, I would say, probably around there. And at that point, whatever it crossed on the graph, I'm going to say that the world population in 2010 was around 7 billion people. How much did the population increase between 1950 and 2010? Well, I'm going to say 4.9 billion because it went from 7.0, from 2.1, it went to 7.0, which is going to be 4.9 billions.